Morning, everyone. I do talks all over, but honestly, back to Bures, this is one of my absolute favorite venues, especially the glass hall right next door. Really, really fun. All right, so you've heard a lot of love stories today. You know, it's actually sort of good to take a step back and at this point maybe thank somebody who's very, very key for all of the entire Hadoop ecosystem, Spark, and so on, right? That's the ASF. The Apache Software Foundation is the home for all these projects, and I want to take a time out to thank the ASF because without the ASF, none of us would be here doing all these cool things together. So at Hortonworks, we really think of this whole ecosystem, Hadoop, Spark, and so on, as the data operating system. Now, if you look back in the history of how computing's come along, it's now pretty clear that data is one of the most, if not the most tangible asset that you have, and you want to do everything to actually manage it, operate it, analyze it, right? And what we at Hortonworks every day get up and say is, the vision is that we want to be able to allow every single end user, you don't need these sort of guardians at the gate, right? You want every single user and application to be able to access all the data and share it with all the users and do all the analytics you want, right? And to do that, you need many, many things, right? You need to start with a storage platform, that's HDFS, which you can store all this data, structured, semi-structured, unstructured. Then you need resource management so that you can actually build different applications and more workloads, bring them all together in a common platform, right? It's not enough just to do these two things. You have to have sort of the key features like security and operations and governance and metadata management and so on. And last not least, you absolutely need a great API for developers because let's face it, developers, you guys in the room are the sort of the lifeblood of the system, and making sure that you guys have the access to the best and the most intuitive tools for developing is really, really key, right? So that's why we come to Spark. And why we love Spark at Hortonworks is that it really presents a really, really simplified user interface for end users, whether it's streaming, whether it's analytics, whether it's ETL. And really, for me, the key about Spark, which I get excited about, is the fact that it's really, really made for data science. If you look at how people are looking at data today, we've gone from looking at transactions, what did the customer do on my site, what did he do with my product, to now trying to predict what he's going to do. And that's the real value of data science, right? We've talked about predictive analytics for a long time. It's sort of a buzzword. But I think the really key aspect that people don't realize, and that's the exciting part about Hadoop and Spark, is that you can now do predictive analytics at scale at a very, very fine granularity. You can do it for every single person in this room, every single person in this world, because that's the way you make every single customer feel special, right? In the past, you've had to sort of take shortcuts. You have to do sampling, you have to do clustering, and so on. But really, the value with data science and Hadoop and Spark right now is that you can do all of these at a very, very fine granularity, right? So with that, what Spark has done is sort of democratize machine learning. In the past, you had to buy some commercial products and so on. But really now with open source and sort of democratize machine learning, you really, really have a wide open field. Last not least, community is really, really key, right? You guys would not be here but for the great community that's engendered around Spark. Particularly, again, want to thank the ASF for it. And overall, it's really helping to realize the value of the data operating system. So Spark is becoming one of the absolute key tools in the box here. So it's fun to talk about the technology aspect, but really, I think it'll be interesting to see what people are actually doing today with Spark, right? This is a small sample of what our customers at Hortonworks are doing with Spark. Now, WebTrends is somebody who's probably very familiar with. They've been a very, very early Spark adopter. In fact, they've adopted Spark for such a long time, and they've contributed that folks like Sean, who's at WebTrends, is one of the contributors at Spark. So what were they doing before, right? In the past, they were just doing batch analytics to do WebTrends analytics. They provide a service, WebTrends, so that you can go in and put some cookies and so on, and they'll give you analytics on top of what people are doing on your site, right? So in the past, they were just doing batch analytics. They migrated over to Spark a little bit early, and they had a separate Hadoop cluster and a Spark cluster. It was really hard for them to manage their infrastructure, right? So today, you fast forward, what they do now is they have a single shared cluster. They have Yarn to manage their other workloads like Hive and so on. And they have Spark streaming to actually ingest all these events. They're talking about billions of events, 10 billion events a day at 20 millisecond latency. So all these events are clicks and ad impressions and so on. And then they use Spark ML for predictive analytics. What they're trying to do is actually they're trying to classify users and say, is this user going to abandon, in this session, is he going to abandon this product or is he going to buy that product? Now, if you feel like he's going to abandon that product, maybe you want to give him a coupon or a discount or whatever it is, right? And they do this now in real time while the sessions are active. So as you can imagine, this is really, really valuable from a revenue perspective for both veterans and their customers. Let's talk about something even more mainstream. Let's talk about insurance. So as you guys know, claims reimbursement is a really, really big deal, right? So when a claim comes in, you got to figure out if it's fraudulent, if it's under-provisioned or over, and so on. And in the past, a customer of ours, this in the Midwest of the U.S., they would actually use R, right? So they'd use R on a single machine, so they'd sample the data set down, and they'd use something like a random forest implementation to do analytics on a really, really small scale, anything that can fit in one box, right? Now, the other problem they had is they really couldn't do things like text analytics. To give an example, if somebody had written, I am now making a fraudulent claim, in the claim itself, they would ignore it because they didn't have the means to process it, right? Funny. Now, what they do today is they've actually migrated from R to run all of this on Spark, right? So now they can use both text analytics and other analytics capabilities in the same platform. And more importantly, they can do it at scale, right? And you're talking about literally tens of millions of dollars that they're saving today because of the fact that they can do it at scale with all of the sort of more modern analytics functions they're using today, right? So really, really key use cases that we're seeing in the platform today. Now, let's talk some more. Now, these are a couple of use cases I talked about, what we've done in the past, what is happening right now. So entity resolution is a big deal. So you go to healthcare, we work with a number of hospitals, a number of big insurance firms and so on. The healthcare providers, they get a lot of feeds. They get a feed from a healthcare provider, they get a feed from a doctor, and you have to figure out if it's the same user. It might be John Smith and Jay Smith. You got to figure out it's the same user. This, it sounds easy, but it's a really, really tough problem, right? Now, there are absolutely no standard packages available to get this done, and you also need to be able to take off additional features to be able to disambiguate. So, for example, if Jay Smith and John Smith have the same address, you now have a better, you now are more sure that it's the same person, right? So again, this is something that we at Hortonworks want to contribute back to Spark as a more general purpose solution rather than you guys having to put together all these algorithms on your own, right? And we want it to be sort of an extensible framework so you can do both supervised and unsupervised learning. Similarly, in finance, we have a customer, one of the really big financial firms. They use HBase today as sort of their store of records. So as you have all these stock quotes come in, they store that in HBase. You have company events like key events like earnings, stock splits, and so on and so on. They store all that in HBase, right? Now they wanted to open this up so that their customers can actually do end-user analytics based on a Spark-based platform. And to do that, we've been working with them so that we can actually give them a really, really fast path to get Spark to deal with HBase. So with HBase, you can do things like predicate pushdown inside as a co-processor. If you guys are familiar with how Apache Phoenix works, that's what it does. You actually write some code which actually runs in the region server, and we want to be able to expose that through to Spark in a first-class manner, right? So it's a sampling of different use cases. So let's talk a little bit about what we want to do given this scenario of what our customers are doing, right? I always find it useful to actually build software in the context of what people are actually doing. So with that background, some of the work we're doing is obviously innovating at the core, right? All the way from, we now have an HDFS in-memory tier, so you can now use Spark RDDs and data frames and so on, and can be cached in the in-memory tier. We want to do better resource management with Yarn. For example, one of my colleagues helped to put in dynamic executors with data locality for Spark when Spark comes in with Yarn, right? Security is a big deal. Governance is an even bigger deal. As Hadoop becomes sort of the storage of platform of record, you want things like metadata to be automatically captured as your Spark applications run. And that's what you do with Apache Atlas, which is, again, a governance and a management framework for data, right? Last but not least, operations and deployments is huge. So we've been doing a lot of work with Cloudbreak. Maybe many of you are familiar with Cloudbreak. We actually acquired a company based in Budapest, Hungary. And what Cloudbreak does is it makes it really easy to deploy Hadoop clusters. So a lot of our customers are now using Cloudbreak with Ambari to deploy a data science cluster. So a data science cluster on Google or a data science cluster on Microsoft, along with things like Apache Zeppelin, right? Now, as you innovate the code, clearly, like I said, data is one of the key assets. We want to make it easy to access all sorts of data in the Hadoop ecosystem through Spark. So we've done a lot of work in the past. With Spark 1.5, we have Hive ORC, which is sort of the standard storage format for Hive. That can easily be accessed through Spark now. Similarly, HBase, we talked about the work we've been doing for the financial guys. And last but not least, we at Hortonworks acquired a company called Onyara, which does Apache NiFi. You may have heard of it. And NiFi is great for the IoT sort of use cases, right? Where you can actually collect data from the edge, from your devices like mobiles and cars and so on, right? So we want to be able to hook up Spark so that the NiFi streams can easily be accessed and processed in real time. Last but not least, one of the areas we really care about, and we spend a lot of time at Hortonworks, is on data science acceleration. And data science acceleration, for me, has many, many aspects. One is, we want people to be able to get data and sort of visualize it very, very fast, right? Most data scientists will tell you 80% of their time is spent cleaning up data, finding the right data, and so on, which is where Zeppelin comes in. Zeppelin is a sort of a notebook, web-based notebook. I'll talk a little bit more. Similarly, we want to be able to provide great data science libraries, not just individual algorithms like LDA and so on, but sort of full packages so that users like yourself can actually spend as little time as possible getting your entire workflow worked up through Spark, right? Similarly, we've been investing a lot in the core machine learning capabilities, sort of one versus rest, serializing machine learning pipelines and data loaders for public sets. The last one is really important. There's a lot of public data sets, and it takes a lot of time to load it. So we want to be able to make it really, really easy for you to access all these data sets. For example, in Europe, you can find lots of public data sets about geospatial data, right? So if you're not familiar with Zeppelin, this is what it looks like. It's sort of an open notebook. There was, again, sort of, this came from a small company in Korea, NF Labs. They might be around here. So again, a shout out for them. It just, again, shows the value of the community. So every day we see new innovations come from all over the world. It's really exciting to see. So what is Zeppelin? So Zeppelin is just a web-based notebook for analytics. And you can do things like data visualization, experimentation. It's completely Spark-based, right? Last but not least, like we talked about the core contributions we're making. One of the things we're really excited about is Magellan. Now, you might have gone to the talk yesterday from Ram Sriharsha, my colleague at Hortonworks. He's the guy who's been behind the project. Now, what Magellan is it brings really, really simple and easy geospatial analytics to Spark, right? Now, why is this important? As you can see, geospatial data is really, 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 really useful in a lot of contexts, right? So if you want to serve an ad, you want to know where this person is. Is he in front of Macy's? Is he in front of Tesco, right? That's one. You want to do things like traffic analytics. You want to do crime analytics. All of this is really, really enhanced by having geospatial data. Now, what Magellan does is it makes it easy for you to take all these different kinds of geospatial data, parse it out, and bring it in a standard format like polygons and so on, right? It gives you a simple and intuitive syntax, so you can actually now do simple geospatial analytics without having to worry a lot. And remember, there's a lot of issues with geospatial data, right? Because every different country looks at geospatial data in different formats. What you find in the US is different from what you'll find in Europe. And Magellan attempts to sort of harmonize all of this, so that as a data scientist, you don't have to spend too much time, munging data around, right? And there's a bunch of blogs and so on that you guys are welcome Ram and I are going to be in the booth over, so if you guys have questions, feel free to come by. So let's actually put all of these things together. Like, we talked about the work we're doing in data science. We talked about Zeppelin. Let's see how easy it is to put together, right? So let's talk about the use case. The use case is something you may be pretty familiar with it, which is I'm an Uber driver, right? Where should I hang out to get the most revenue, right? Because you're all over the city. Where should I hang out to actually make most revenue, right? Now, here's what you could do with something like Zeppelin, right? First, you load this data up, right? As you can see, Magellan and Zeppelin make it really easy to load it and sort of visualize it. And you sort of join it with take your Uber data. Uber actually, it's really great. They actually publish an anonymized data set. So you can take that anonymized data set, join with the geospatial data, and you can start to look and say, at what timestamp, what trip started at what neighborhood, right? So next, what you can do is you can say, which Uber trips are passing through which neighborhood, right? So you can now join all this data, join your trip data with your neighborhood, and sort of group by and say, who is going where, right? Similarly, you can say, all right, now that I know where the trips are passing through, let me look and see which neighborhood has the most Uber trips which are starting, right? So it shows that in south of market, which is Soma, you actually get a lot of trips starting, right? Similarly, you want to now check how many trips start in Soma but also end in Soma. So you can now go back and say, OK, I've got a bunch of trips starting in Soma, a bunch of trips ending in Soma, so maybe I need to hang out at Soma, right, which is south of market. With that, hopefully you get a sense of all the work that's happening in the Hadoop ecosystem with Spark. And again, I want to take this opportunity to thank Databricks for having us over, and also all you guys for taking time to come talk to us. With that, thanks.